Hello and welcome to Unprofessional Engineering. My name is James.
You got Luke.
Luke, today we're discussing nuclear waste disposal.
So for the record, James, I was under the impression, like we had our battery and recycling episode a while back.
You
Check
just
it out.
put it in a bag.
I would just put it in a bag and just throw it in the garbage, right?
If it was mine for my personal reactor at home, yes, that is the right way to do it.
It's just little pellets of uranium. I mean, you throw it in with a cat litter, pack it, put it in the double bag it. You want to be courteous, double bag it.
You're being safe.
Yeah, double bag it and just put it out with the regular stuff. I just assumed that's what like governments and nuclear regulatory agencies and all these reactor places, I'd assume that's what they did.
Based off of my research, it's not far off. Luke.
It is not far off. You are absolutely accurate.
So I got a lot of my information from worldnuclear.org. And let me tell you, they have a very sunny outlook on all of this. They were really trying to sell me on nuclear waste not being all that bad and all of these different things that are worse than nuclear waste. So I thought it was very interesting.
But the thing that I found interesting was I used that website as well. So we might have some similar facts. But I also found some very, I'll say, green websites that were all about, the Mother's Earth and the
Mother's Earth
and the nuclear, waste and nuclear technology is like the worst thing that's ever occurred, and we're going to kill our planet. And so this is definitely, I'm going to say, one of the more politically volatile things that you and I've talked about. And we're not going to take a stance one way or another, whether you believe in nuclear energy or not. And bombs. It is what it is. And we're just going to talk about how we deal with it when we're all done using it.
That's right, Luke. That is what we're going to do. So from the worldnuclear.org, it's not the world, but from the website worldnuclear.org, all toxic wastes need to be dealt with safely.
Mm-hmm.
Not just radioactive waste. And in countries with nuclear power, radioactive waste comprises a very small proportion of total industrial hazardous waste generated. Radioactive waste is, in fact, not unique to the nuclear fuel cycle, Luke. Mm-hmm. Radioactive materials are used extensively in medicine, agriculture, research, manufacturing, mineral exploration, all sorts of stuff. Unlike other hazardous industrial materials, the level of hazard of all radioactive waste, its radioactivity, diminishes with time. So not only do these reactors barely make any waste that's not all that bad, but it becomes less bad over time. So really, according to worldnuclear.org, this is barely a problem.
Of course. What's the half-life? Like half a billion years? Eventually, it'll be okay.
Right.
They're more concerned about people pouring paint down their drains than they are about nuclear material that has a half-life of 500,000 years.
Not that you would pour paint down your drain.
No, right? I don't. No, I don't. I double bag it, goes in the garbage. So that makes me beg the question, right, James? So what actually is nuclear waste? And it's funny, a lot of places don't call it nuclear waste. They some do, but when it's specifically fuel for nuclear reactors, they call it spent nuclear material, meaning it doesn't have the capacity. And the reality is, they say that spent fuel rods still have 90% of their total energy available in them. It's just not feasible from a financial standpoint and working with the standpoint to keep it at those lower output levels. So some countries reuse this. I think you might get into that a little bit, but so it's not just like waste. Like when I think of nuclear waste, I'm thinking of the movie Chernobyl. I think I pronounced that correctly. And like all the cleanup stuff that touches it is also considered nuclear waste. So decontamination units, wrenches, mops, buckets, like all the things that work inside of a nuclear facility become nuclear waste and have to be dealt with differently. So I have two broad categories. What do you got?
I have three broad categories, but let's hear what you have to say. How about that?
So the first one, so it's high level and low level, pretty straightforward. And
I have intermediate, but basically.
So high level is kind of what you think it is. This is stuff that comes out of a nuclear reactor. It's a spent fuel rod, and it's all the components, the little pellets that sit inside that fuel rod. And then low level waste is the medical waste you spoke about. It's things inside of a reactor that become radioactive over time that you can't throw that wrench in your toolbox and take it home and work on the truck, because
I suppose you could.
Well, you'll be like Homer Simpson. You'll be glowing by the end of the episode. So these are things that are used for academic, industrial purposes, and it's not as kill you-ish as the fuel rods.
I think that's the technical term, is kill you-ish.
Pretty sure.
They measure it in units of kill you.
Yeah. So those are the two broadly, and then there's intermediate ones that you spoke about. I didn't get any detail on the intermediate. What was the intermediate stuff that was different?
Oh, just different levels of kill units, basically.
Okay.
I love how you can just like boil this stuff down. Like I have all of this stuff written out, and you're just like, one really kills you and one kind of doesn't.
No, I know. I learned everything I need to know about nuclear waste disposal from Homer Simpson. So
that's fair. Anybody who hasn't watched The Simpsons, go do that. You don't need to listen to us anymore.
But I thought he worked at the beer place.
No, Duff Brewery. No,
I thought he worked at Duff.
No. He's a big supporter of Duff. I'll tell you that much.
Okay.
But no, he does not. He works at the reactor. Maybe there was an episode or two where he worked for the brewery, but I don't know.
Okay.
More importantly, high level waste is sufficiently radioactive for its decay heat, greater than 2 kilowatts per cubic meter. All sorts of bad stuff there. This is like the used fuel that you're talking about, and all that bad stuff. The other two have lower levels than that. We could go into more detail. I don't think we really need to. The low level stuff, though, really is like paper, rags, tools, clothing, stuff like that. And it mostly has a short-lived radioactivity. It's reduced in volume. It's really compacted. It's incinerated a lot. And it makes up about 90% of the volume, but really only 1% of the radioactivity of the waste. Then you get to the high level stuff, and that's where it makes up just 3% of the volume, but it makes up 95% of the total radioactivity of the waste. Most people think of this, I think, when we're talking about this.
So you're talking about volume. So I was going to save this fun fact for later. It's an amazing fun fact. So
is it a good one or a bad one?
I guess it depends if you like radioactive material. So the United States alone generates 2,000 metric tons each year of spent fuel. So a metric ton is actually equivalent to a regular ton is 200 pounds more. So they're kind of
like
close.
1,800 pounds.
It's higher. So
it's 2,200.
Yeah, 22. So and it's funny, the website, I think it was this World Nuclear Association page.
Nuclear, we love.
Yeah, it was like
poisoning people.
This number may sound like a lot, but it's actually quite small. In fact, the US has produced roughly 83,000 metric tons of used fuel since 1950. And it's like, okay, 83,000 metric tons doesn't seem like a big deal. And then they add, it could all fit on a single football field at a depth of 10 yards. So, you know me, I'm great with the maths, right?
You are good at the maths. I know that.
A football field, including the end zones, is 360 feet long.
Now, did they include the end zones or
I'm
not?
assuming they said football field. My guess is they were going to take the whole football field. 360 feet long, including the end zones, 160 feet wide, and they said 10 yards deep, so that would be 30 feet tall. When you do the math, James, you do 360 times 160 times 30, you end up with 1,728,000 cubic feet of spent nuclear fuel. That seems like a lot to me. Like, I don't know.
But it's one football field. That's all. There's football fields everywhere.
Well, I guess. No? And I guess if it's the Detroit Lions Stadium, we're good.
I was going to suggest that we go do this in Tampa Bay. I mean,
or Tampa Bay Stadium, one or the other.
TB12's had a good career. Antonio Brown's there. I don't mind him playing on that field.
Yeah,
that's mean. Oh, that's really interesting, though. You're right. That's that feels like a lot to me.
It feels like a lot.
especially for some of the current solutions that they have for dealing with this waste. One of the solutions is reprocessing used fuel, which I find to be very interesting. A fun fact about this before we take our first break, about 20% of the electricity in the US comes from 96 commercial nuclear reactors, according to the US Energy Information Administration. And roughly every 2 years, Luke, each plant replaces about 1/3 of its fuel with fresh fuel. And so, as you said, there's still lots of power in there, and we'll get into the process of reprocessing right after this word from our sponsor.
I have to assume it's this website you were talking about.
It is not, but this episode is brought to us by the Big Compute Podcast.
Nice.
Let's take a listen.
What can computational science tell us about the tsunami generated by the biggest earthquake to ever hit Europe? Before you know it, everything is shaking, and shaking loudly. What makes the coronavirus so contagious?
It's the machine that literally will latch on to your human cell and ultimately infect you.
And what was it like when a massive act of cyber warfare stopped an entire country in its tracks? Their ATM greets you with red text over a black screen. This is really starting to creep you out. These are just some of the questions being answered every day through the power of computing. And on season 2 of the Big Compute Podcast, we transport you to the heart of these stories, giving you a first-hand look at how computational science is changing our world. Find the Big Compute Podcast wherever you get your audio, or visit bigcompute.org.
All right. In addition to that great sponsorship, thank you very much, Big Compute. We have a couple of shout outs.
Who do we
some
got?
Of our great listeners.
Homer
Bryce
Simpson.
H. Homer Simpson, aka Bryce H. Love the podcast. I listen to it almost daily. We need to work on that, Bryce. Get that up there to daily. While I work as a mechanical engineer. Yes, mechanicals.
Nice.
I found myself randomly laughing throughout the day. So thank you for that. People might start to question Bryce here.
Your sanity, yes. I'd
Yes.
keep that to yourself.
I've listened to 50 plus of your episodes. Some of my favorites are Cooking the Perfect Pizza and the Venice one.
That's a recent one, the pizza one. And you
both of
poo-pooed
those are
that, I
pretty
believe.
recent.
I think
did
you poo-pooed
that.
pizza.
I did. I'm
Okay.
glad that Bryce likes it. Our dynamic together, Luke, is great, and it makes a great show. So thank you, Bryce.
Batman
I
and
appreciate
Robin.
it. Matt S. also wrote in, "Hey guys, I just recently started listening to your podcast on Spotify, where you're not allowed to give reviews, but that's okay. And I've gotta say, your podcasts are goated." I don't know what goated is, Luke, but
Is that a good thing?
I assume it's good. Maybe it's like goat. Like maybe we're like the Tom Brady
Goated?
of podcasts. So we're
Okay.
goated. Also, I really enjoy your episode on wind turbines. My opinion, the steam engine is the most ingenious thing ever created, because to use the power of compressed steam to move hundreds of thousands kilos of solid metal, that's just insane. I agree. And I don't know if that made our top 10 inventions list or not, Luke, but it does feel like it could be up there. Also, listeners, this is a me saying, go check out MS Aviation. I don't know if it's his company or not. It kind of feels like it, but it was rather impressive. And when we are in need of a private jet, Luke, which I think will be soon based off of
What?
our growing popularity,
Yes.
Matt might be able to hook us up.
Just the
So-
hookup.
If any of you can give us a deal on a private jet, maybe wrapping it with our smiling faces on it so that we can fly around the world and
Nice.
meet all of you. If you want some amazing stickers, maybe we could just slap those on our jet. If you have suggestions for episodes, or if you want to sponsor us, feel free to email us at unprofessionalengineering@gmail.com.
And don't forget to subscribe, like, review, and as always, you can tell your smart device to play the Unprofessional Engineering Podcast.
That is right. Man, you sound like such a radio host. I love it.
Yeah, sorry.
All right, reprocessing used fuel, Luke.
Let's hear it.
Any used fuel will still contain some of the original U-235, so that's uranium for those of you who don't know the U's.
The most
as well.
popular of fuels.
Is it the most popular of
I think it
fuels?
is, yeah.
Are the other fuels jealous of it?
Probably.
Okay. As well as various plutonium isotopes that have formed inside of the reactor core. And U-238, apparently the slightly less popular version of the U's. In total, these account for some 96% of the original uranium and over half of the original energy content. That's crazy town. So in my brain, it says, all right, let's reprocess this used fuel and get more out of it. But like you said, maybe not the most cost-effective procedure. Reprocessing allows for a significant amount of plutonium to be recovered from the used fuel, and this is then mixed with depleted uranium oxide in a MOX fabrication plant to make fresh fuel. So again, sounds all good. This process allows something like 25 to 30% of the energy to be extracted from the original uranium and significantly reduces the amount of high-level waste, about 85%. So I know this is super expensive and not really cost efficient, and it isn't done in a lot of countries. But I mean, if you're reducing the waste that much and you're getting to reuse this stuff, why wouldn't we be doing this?
I think we just need to go to nuclear fusion. If you haven't checked out our nuclear fusion episode, check it out, because there's no radioactive waste whenever you're combining atoms instead of splitting them. Come on, people.
You are right, Luke. Get on that science.
Only need like a billion degrees. You only need like a billion degrees Fahrenheit in a vacuum to do it, right?
Yeah.
How hard could that be?
There are, if you're not going to go with this, there are commercial processing plants available and operating in France and in Russia.
Yeah.
Another's being commissioned in Japan for them to do their own, and China plans to make one as well. So it is becoming a more popular thing to do. France, at the current time, though, undertakes a lot of the reprocessing for other countries. Like Japan sends all of its fuel or a lot of its fuel there to be reprocessed until its factory is opened up. So that's all I have about reprocessing of fuel. What do you want to talk about next, Luke?
So let's actually talk about like how they're disposing of it, or what some of the options are. So let's say you're done with these nuclear fuel rods, or the subsequent materials that are associated with it, or medical supplies, whatever it is. Like, where do these things go? So in most cases, nuclear fuel, the fuel rods themselves.
If you say 2 bags and thrown in the garbage, I'm going to come over there and hit you.
No. I'm not going to say that. No, what they do is most nuclear facilities, so reactors that are generating power, most of them probably have what's called a retaining pond. And basically it looks like
I have one of those like in my neighborhood.
No, different. So this looks like an Olympic-sized swimming pool that you would never want to go into. And the challenge is these nuclear fuel rods are like crazy hot. Like the reaction is still happening inside of these rods. So they're, super hot. And what they do is they put them in, they call the initial cooling phase. So they have these big, giant, long pools. These pools tend to be about 4 meters deep, and they're big, long pools. And they basically, you just look, I saw pictures of them. There's just pictures of these nuclear fuel rods sitting in these giant storage ponds. And that's like a short-term kind of fix. They said somewhere in the neighborhood of 4 to 5 years, they will sit in these and cool. Then they move them to what are called like dry storage. So now it's not crazy hot, but
it's just super hot.
It's just super hot. And what they do is they put these big like concrete, I'll say canisters, caskets, I think they call them. And there's all this crazy, double secret probation, make sure it doesn't break stuff surrounding it. And they put them in what's called dry storage. And sometimes this is above ground, sometimes it's partially below ground, but they just use convection and air moving over these caskets to actually cool them passively. There's no active cooling mechanism. It's all passive cooling with just air circulation. So those are the two that happen like on a site, typically at a nuclear facility. And I know you have some experience with this. We can't go into it because we'd have to kill everybody that listens, because when you were a secret agent. But I imagine you have some feedback on these.
I do. So like the process that you're talking about, is where I spent a bit of my time when I was in the industry, we'll say. But first, a fun fact for you, Luke. When Michael Phelps was a child, he actually swam in one of these Olympic-sized nuclear fuel repositories.
That's why he's so good.
Yeah, unparalleled skill. Yeah, that is what happened. So it made him kind of freakishly long and gangly. But other than that, I mean, I think it's worked out for him.
Oh, it's definitely worked out for him.
Yeah. But realistically, like you're saying, that's kind of how it works. You stick them in this big swimming pool, and then eventually you can put it in these caskets or whatever you want to call them. Now, I won't go into too much detail, but when I was working on this stuff, a lot of it was around just the safety of transporting all of this. Nobody wants a bunch of spent fuel traveling around the country, right? And you have to be super, super, super safe with the way it's done. And just at a super high level, you basically take all of these different rods and you place them into baskets, which are kind of like, imagine like two big metal rings with fuel rod shaped holes cut into them. And it depends on the design, but you put however many in these baskets, and you can stack a few of these baskets on top of each other. And then they go into, like you're saying, these caskets, and then into these giant, super thick steel containers. And that's what they're used for shipping. And they're so cautious about this, as they should be. They're only allowed to take certain roadways or pathways, trainways, whatever, railroads, to get where they're going. And you have to analyze this using FEA and whatever else. You have to do the CFD, heat transfer analysis, and then you have to do the FEA analysis where you're taking the largest possible drop. So let's say there's a part on this path that it travels that's 30 feet. You have to be able to ensure that this canister can drop the full 30 feet, hit at any possible angle on a surface that they consider to be infinitely hard. So let's pretend that it's like concrete with rebar underneath you, even though it never is. It has to be able to withstand that without any issue in case the worst possible happened. And that's the kind of testing that they end up doing for this sort of stuff to ensure our safety.
One of the coolest testings I saw, and you may have seen this before, and you know me in my videos, it was a train transport unit. And basically, this is like steel inside of steel, inside of steel, inside of steel. Like these things are, and what they do is they take a train and they hit it with another train. And at like full speed, however fast a train goes. And this thing, like, it had some dents on it, but like they went over and they, opened up the key and everything, and they were able to open it, and the stuff on the inside wasn't, I imagine it might be like those, remember those engineering challenges where you put an egg and you have to drop it like 10 feet. I wonder if that's how they test it. They put an egg inside of it, like suspended, and see if it breaks.
Yeah, no, it's very interesting. Those were the things that I would design for a lot of my time. And I always was like it's like a foot thick or something. There's nothing that's going to happen to this thing, but it's so over designed. One other thing, when I was working there was actually an accident. I think there was like a Jeep broken down on a railroad track and a train smacked it that was carrying some of the low level stuff.
Oh no.
And this is how not serious some of this stuff is. Like there were parts that were scattered across I don't know what county it was, but somewhere here in PA that was being shipped off to another facility. And it was a big deal, but it was totally like hushed, but nothing really special happened. They got out there with their special suits, they packaged it back up, and they went on their way. But there wasn't any big deal because it was so low level. Before we go on with more about storage, let's take a break for this week's Luke's Rant.
Okay, here's my rant, James. We're wrapping up the pandemic right now, depending on when you're listening to this. It is,
and depending on where you live.
It is May 21st, roughly, in that time frame, and things are wrapping up. And
in America, Luke,
yeah, at least here in the United States, restrictions are lifting. People are getting vaccinated, yada yada yada. And I realize that I've let myself go, James, a bit. And
I was just thinking you look svelte.
Well, it's the black t-shirt.
I see.
But my wife informs me that she wants to get a Peloton. So she apparently has some foot issues. So like doing running or aerobics or high, it just, her foot just it is really difficult, super painful. So she's like, oh, a lot of my coworkers said these Pelotons are great. And I was like, oh, okay. And I've heard about Peloton. Like everybody we work with has a Peloton, and they're all like a bunch of Peloton groupies. I get it. I look at how much these things cost. So like the cheap one is $1,800. And keep in mind, this is a bike that doesn't move. It's not like I could go places on this bike.
Yeah.
The bike that doesn't move, it's $1,800. And you still have to pay like $40 a month for a subscription.
That's the kicker, man. That's the kicker. You put that money down to buy it, and then that much every month.
Talk about a great business model that totally rips people. But everybody I know says they love them. So we have a couple coworkers. Jim B, he got one, and he says he loves it. Yeah, we got lots of people I know that say they love it, but like for me, it's just like I don't know. If I want a bike, I want to go somewhere on a bike. But so I might be buying a Peloton. So we need some more sponsors.
We definitely need some sponsors.
Yeah.
I agree with that.
Peloton.
We got one for this
What?
episode, and we appreciate it.
I don't even need money from Peloton. Just send me a bike and
Yeah, Peloton, send
give
it
me
to
a
us. You love
lifetime
your
subscription.
community.
Yeah,
Yeah, I want one. I want one as well. If we're going to be asking, my wife actually subscribes to the Peloton app, but doesn't. When you don't own the bike and don't need it to connect to it, it's only like $15 a month.
Oh, and you
which
get all
doesn't
the
make
and you get all
sense
the
to me.
exercisey stuff, right?
Yeah,
That's
but she
non-bikey.
uses her spin bike to just
okay.
match up with it, which is very strange. I do have friends with Pelotons though that really love it. So great system, great community that they're working with. But yeah, very expensive.
Keeping people fit.
Peloton, we love you. Send a bike our way too. Actually,
Sure.
back to the storage, Luke.
Okay.
The low level waste that
Low
we're
level.
talking about as well. It doesn't have the same procedure that these spent fuel rods and stuff
Double
have.
bag it.
That's basically what they do. They double bag
It's
it,
crazy.
and then immediately it's sent off to what they call near surface disposal facilities. And again, this makes up 90% or more of the volume of this type of waste. There's facilities everywhere. The UK, Spain, France, the USA has 5 different low-level waste facilities. Texas, New Mexico border, South Carolina, Utah, Tennessee, and Washington. You all have some, so keep an eye out in case you start growing another arm. Something that really freaked me out though, Luke, some low-level liquid waste from reprocessing plants. What do we do with that? We discharge it to the sea. That doesn't make me feel real good. I mean, I'm sure there's been tests run and all that, but I mean, this is how Blinky got formed in The Simpsons.
It is. The distribution of it, I think, is probably safe, but just the thought of it doesn't feel right.
Yeah, it doesn't feel right to me either. One fun fact for you though, Luke, and this is again from the Nuclear Waste Isn't So Bad website. Nuclear power is the only large-scale energy producing technology that takes full responsibility for all of its waste and fully costs this into the production. So that's interesting. Most nuclear utilities are required by governments to put aside a levy like 0.1 cents per kilowatt hour in the US or 0.14 in France to provide for this management and disposal of their waste. So that's kind of cool that they have to do that.
Yeah.
But to call that out as something like really special makes
our
me
stuff
giggle
is
a
so
little bit.
bad we have to pay for it ahead of time.
Yeah, exactly. That's another way to look at it.
Yeah.
So I have one more thing about storage, which is how they're going to do it, maybe.
Yeah.
But do you have anything else other than this that you want to talk about?
So before you get there, I just want to point out, like, I started doing all this research, right? And everything I was reading, we talked about this right before we recorded, was I was reading and everything kept on saying proposed. And I was like, it's like, why is this all saying proposed?
Yeah.
The reality is right now in the world, there is no permanent / extra long-term storage for nuclear waste. Like right now, it's retention ponds, it's
the dry cast,
it's dry cast, it's some of the near surface disposal for the low level stuff. But most of this stuff is proposed. It isn't actually happening. In some cases, they are putting this in caves and they are doing some deep geological disposal. But even the deep geologic disposal is still considered kind of temporary-ish because they just don't know what the long-term viability of these locations are.
Yeah, I kind of buried the lead on this one for you. So sorry about that.
You did, big time.
Yeah, but it's still very interesting, I think.
It is very interesting.
Do you want to talk about this super deep geological stuff, or do you want me to?
You can.
Okay, sounds good. So, like you said, the casks and the waters and all of that stuff is currently like the short-term solution, we'll say. And by short-term, we mean only one that's been happening since this stuff has existed, which, like you pointed out, isn't that much waste. It's only a giant football field dug kind of deep into the ground big. So that's good. It's also not really expensive to store this way in the grand scheme of things. But another thing that they're looking to do is this, what did you call it? Like deep geological whatever storage. I have it written here: deep geological repositories for nuclear waste. So a bunch of different countries are looking into this, the United States being one of them. And what is it? Yukka Mountain or something
Yucca,
like that?
still not happening.
So it's been proposed that we dig a big old hole underneath this mountain and we stick all of our waste in these tunnels, and that it will then forever be there to be safe and sound. And, its half-life can continue to eat away at the radioactivity. Good or bad, I don't know. I'm not one to decide that, but the government has kind of flip-flopped on this, probably depending on who's
multiple times.
President.
Yep.
Yeah, and who's in control at that time. Multiple times, so that this project has never really gotten off the ground, we'll say, or at least it's not to a point that it's functional in any such way. That being said, Onkalo in Finland, which translates to cavity, is a series of tunnels in a mountain where they're going to be storing high-level radioactive waste. So this is for really long-term storage. And so how long is long-term? We're talking about 100,000 years plus.
Wow.
So if you say 100,000 years, I mean, that's forever, right? It's not going anywhere after that. When it's complete, it's going to be able to store all of the high-level waste from the past century and more. And it will consist of 60 kilometers of tunnels that are dug underground. So
I know where to send my batteries now.
Send your batteries double bagged, and then it'll be safe for everyone. So this is the same thing as what they have proposed in the United States as well.
So there's a whole bunch of different, there's some ideas out there that, so the one you just talked about, long term, the geological, but there's some ones that they're thinking about or experimenting with, and I have to review these. They're pretty funny. So the one is disposal in outer space, and this is probably the one to me that makes the most sense, because literally well, hold on, hear me out. Just get it off of the Earth and just put it somewhere where it's not going to cause any problems. The problem is if the rocket explodes. Like, think about just SpaceX. How many
terrible idea?
Like, how many times the rockets have exploded? Like, if that happens, like, whoever's around that's going to be in really bad shape.
Didn't we just have a really big issue with like a piece of like a Chinese spaceship or something coming back to Earth, and we're like, well, we don't know where it's going to hit. So now we have this nuclear fuel filled rocket flying back at Earth, exploding on us. That's great.
I like that one, but it's financially not
Let's
feasible.
Hear some of the other
options.
Other
one is called rock melting. So you drill this giant hole in the ground in really hard sedimentary rocks. You put the nuclear fuel down there while it's hot, and you just let it continue to react. And what it does is it melts all the rock around it and encases itself. And then once it cools, it's just this big radioactive blob that's, hundreds, if not thousands of feet below the surface. Seems reasonable. Investigating, nobody's doing it. Another one is called disposal in subduction zones. So subduction zones are where you have two plates on the Earth. And the one is subducting, going below.
So it pushes it under there.
And the idea is just sweep it under the rug. Right? You just lift it up.
That works at my house. Why not here?
It does. I mean, come on. Where do you put your toenail clippings? I mean, come on, right?
Oh, you're so gross.
So then there's sea disposal, which you talked about, seems bad. Subsea bed disposal also seems bad. And then
anything
the worst,
having to do with near water seems bad.
And then the worst of all is disposal in ice sheets. So you go to the ice caps and you just drill giant holes and drop
and
stuff
melt
in
the
there.
Ice caps. That's great.
It's just So I think the challenge is long term. It's really difficult to know if any of this stuff is good.
Yeah. So something about the long term. So all the stuff that I talked about with the drilling a hole in a mountain or underneath a mountain, basically they're going to keep doing that. And then, unlike what you're saying, where they just dump this stuff in there, they're going to keep it in these casks or caskets or whatever we call them, and then bury them. And then they backfill the tunnels, right? So that they keep filling each tunnel up. And once they're all filled, they're like, well, then what do we do? And they've had all of these conversations about Do we put up signs? Because they're like 100,000 years. Who knows what's going to happen, right? Humans could be gone by then. Maybe another civilization shows up and they're like,
what's
why are
this?
there all these warning signs? Just like the pyramids, right? We're like,
Yep.
well, we got to go in there because that's got to be something cool.
For sure.
And this is the same thing. They're like, do we just like put up warning signs and hope they recognize what it means? Do we leave it completely unmarked and just hope that they never go under this mountain? Like all of these like problems that they're trying to come up with to solve, which I just find to be extremely interesting.
Super quick game before we end, James.
Oh, yes, please. Let's do it.
Okay. I want you to name 2 states that don't have nuclear waste storage.
New York.
Nope.
Don't have Florida.
They have 3.
Oh, I don't know. Somewhere in the that don't have that. Yeah, Florida. I don't
have.
think.
No,
Hawaii
they do.
And Alaska.
Hawaii and Alaska aren't on my map. So basically,
if
you're safe if you live in Montana, North Dakota, South Dakota, Nevada, actually, because the Yukka Mountain thing isn't happening. Utah,
like all of them.
New Mexico, they don't. So if you think about where these are, so California has a bunch. So there's a bunch in California.
A place I think they shouldn't have them, where they have earthquakes every
You look at the Great Lakes area. There's a lot in the Great Lakes area. And then the East Coast is just polluted with either a nuclear facility that is power generation and they have on-site storage, or it's just a storage facility. In Pennsylvania alone, we have 3 Mile Island, Susquehanna, and Limerick and Peach Bottom are either a facility or that produces electricity and has storage, or just a storage facility. So the East Coast is just terrible for nuclear storage.
That does sound bad. My wife calls me Peach Bottom, so that's kind of weird. Huh. On that note, Luke, I think it's time that we call it a day. Hopefully all of you out there learn something about nuclear waste disposal and making sure that you double bag it, because it is dangerous stuff to get out of your house. If you have any information you want to share on this, if you want to tell us that we did a great or terrible job, if you want to suggest some topics, if you want some stickers, if you just want to say hi, go ahead and email us at unprofessionalengineering@gmail.com. And until next time.
See you later, Peach Bottom.